So this is going to be the Chapter 3, Chapter 4 for Test 3 review that we did in class. So all angles of a triangle should add up to be 180 degrees. So I'm going to take 3x minus 5 plus 2x plus 5 plus 40 and set it equal to 180. So I have 5x, those cancel, subtract 40 from 180, so 5x equals 140. So x should equal 28. Let's plug it in and find our missing angle measures. So 3 times 28 minus 5 is 79 degrees. 2 times 28 plus 5 is 61 degrees. Okay, so 4x plus 4x plus x should equal 180. 4x plus 4x is 8x plus x is 9x. 180 divided by 9 is 20. So this is 20 degrees. 4 times 20, 80 degrees, 80 degrees. Okay, quadrilateral has vertices A, B, C, and D. Show algebraically that opposite sides of the quadrilateral are parallel. So let's graph them to see what my opposite sides are. So 1, 8. Ooh. 1, 2, 3, 4, 5. There's A. 7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 3, negative 3. And negative 3, 0. Okay, so opposite side, so I have AB and DC. So AB, let's do the slopes of that. It is 5 minus 8 over 7 minus 1. 5 minus 8 is negative 3. 7 minus 1 is 6, which simplifies to negative 1/2. Now let's try DC. So I got 0 minus negative 3 over negative 3 minus 3. 0 minus 3 turns to 0 plus 3, so I got 3 over negative 3 minus 3 is negative 6. So AB and DC are both negative 1/2. Okay, and then I'm going to erase it, because on your paper you'll have more space, but I'm going to erase it so I can do the other side. So let's do AD. So AD, so I got 0 minus 8 over negative 3 minus 1. 0 minus 8 is negative 8. Negative 3 minus 1 is negative 4. Negative 8 divided by negative 4 is 2. And then we have to do BC, because parallel lines sit across from each other like that. So BC are right here. So negative 3 minus 5 over 3 minus 7 is negative 8 over negative 4, so 2. Okay, so they're both 2. Remember, parallel lines should be the same. Okay, so now I have to show algebraically that consecutive sides are perpendicular. So let's do AB and BC first. So AB, I got 5 minus 8 over 7 minus 1. 5 minus 8 is negative 3. 7 minus 1 is 6, so negative 1/2. So there's AB. Now let's do BC. So negative 3 minus 5 over 3 minus 7. Negative 8 over negative 4, so 2. Okay, remember perpendicular lines are opposite reciprocals. So one's positive, one's negative, one's 1/2, one's 2. They're reciprocals. Okay, so we know those are. Now let's do another one. Let's do DC and AB. So, or AD, sorry. So AD. We got 0 minus 8 over negative 3 minus 1. 0 minus 8 is negative 8. Negative 3 minus 1, negative 4, so 2. And then let's do DC. So So 0 minus negative 3 over negative 3 minus 3. So we have 3 over negative 6, which is negative 1/2, which are opposite reciprocals of each other. Cool. So write the equation on a line that passes through points A and B. Put your answer in slope-intercept form. Slope-intercept form is y equals mx plus b. Okay, so let's find the slope of AB first, because right now I don't have a slope. So 5 minus 8 over 7 minus 1, negative 3 over 6, negative 1/2. Okay, I'm going to put it into point slope because I think point slope's easier, but you could do it into slope-intercept. So I'm going to get y minus, let's do point A. So y minus 8 equals negative 1/2 x minus 1. But we need it in slope-intercept form, so let's solve it. So y minus 8 equals negative 1/2 x plus 1/2. Add 8 to both sides, so I get y equals negative 1/2 x plus 8.5. Write the equation line that passes through CD and put your answer in slope-intercept form. Okay, so this time it's CD, so let's find the slope first. So I'm going to do 0 minus negative 3 over negative 3 minus 3. So we got 3 over negative 6, negative 1/2. And then let's pick point D, so y minus 0 equals negative 1/2 x minus negative 3. So that changes to a plus. But we need it in slope-intercept form, so get y by itself. Y minus 0 disappears. Negative 1/2 x minus 1.5, because we gotta do negative 1/2 times 3. So there's my answer for that. Okay, proof. So I always start with my given, so we're going to go ahead and write that in there. AB is congruent to DC. Reasoning, given. Okay, so AB is parallel to DC. So let's show that. Let's do my little, those are the ugliest arrows. So AB and DC are parallel. AB is also congruent to DC. Okay, so I want to try my next step. So it looks like they share the same line, this BD. So we could say BD is congruent to BD by the reflexive property. Okay, so now I need to prove an angle or another side. It looks like, since I have parallel lines, I'm probably going to do alternate interior angles. So now I need to find, I have two sets of things that are congruent. I need a third set of things. So if I know that we have parallel lines, I'm going to be using alternate interior angles. So I know my 3 is going to be the alternate interior angles because the parallel lines are the little arrows. Okay, and I need the one angle that's included in my two sides here. Okay, so this angle is included in those two sides, and this is. So I'm going to say angle ABD is congruent to angle CDB. Okay, be specific. Don't say angle D and angle B because there's multiple angles in those. Okay, so now I have enough to prove my two triangles congruent because I have three sets of things that are congruent. So triangle ABD is congruent to triangle CDB by, if I write it, I have a side, an angle, and a side. So by side, angle, side. And that was what we were trying to prove, so we're done there. Okay, so we always start with our given. So GK is perpendicular to FH. Remember, that means perpendicular. And GK bisects angle FGH. Okay, my reason is always the given. So you should be able to get the first two because they're given. So GK is bisecting FH and GK bisects angle FGH. Well, if we have a bisecting angle, that means we know that these two angles should be congruent. So my 2 is going to be angle FGK is congruent to angle HGK by definition of an angle bisector. Okay, so now we have angles. My next one that looks pretty easy is going to be my reflexive property. So GK is congruent to GK by the reflexive property. Okay, and so I need another side or another angle. So I haven't used this information. So I have a perpendicular bisector. So if I have a perpendicular bisector, it's not saying that this is the midpoint. So these two sides are going to be congruent, okay? I just know that there's a perpendicular line. So perpendicular lines should always create 90-degree angles. Okay, so I'm going to say, hey, these are some 90-degree angles. So angle FKG and angle HKG are right angles by definition of perpendicular bisector. Oops. Okay, so we stated that they're right angles, but now we need to state that those right angles are congruent. Okay, so now we can say angle FKG is congruent to angle HKG because, oops, that should have been a 4 here, sorry. By definition of a right angle or right angle theorem. Okay, so now I have 3 sets of things that are congruent, so I can prove my 2 triangles are congruent. So triangle FGK is congruent to triangle HGK by, so let's write it out. I have an angle connected to a side connected to an angle. So angle, side, angle, and that was what we were trying to prove, so we can stop there. So this one's the tricky one. You have to say, hey, these are right angles, and then your next thing you have to say, hey, these right angles are congruent. Okay, an angle puzzle. So let's go ahead and take a look. So let's see, angle A is over here. So let's just fill in some information. So we can say D is 90 degrees because that has a 90-degree angle, and they create a straight line. Okay, don't forget to put your degree sign. And we can find this one here. So 180 minus 150 to find that one. So this is going to be, I'm going to change colors. That's going to be 30. These are vertical angles, so they should be the same, so it should be 88. So now I can add these two together and subtract it from 180 because all triangles should equal 180 degrees. So I'm going to take that and get A to be 62 degrees. So let's find some others. Let's see, this creates a straight line, so I'm going to take 180 minus 65, so this should be 115. Oops, it should be 15, sorry, I was wondering why that was so big. Okay, so I can take 15 plus 120 and subtract that from 180. So I get E to be 45 degrees. Okay, now we got to find some others. So we don't really need any information based on that because there's not any missing angles. So we're out here trying to find B and C. So right now I need to find other information, maybe try to find this by finding these. So I'm going to erase some stuff here so I can find those. So if that's 15, that's 15. That means this creates a straight line, so I take 180 minus 110, so that should be 70. This is a vertical angle, so 110. So 180 minus 110 minus 30, that should be 40. These are vertical angles, so that should be 40. 88 plus 40, and we could subtract it from 180. So this is 52. This creates a straight line, so I could take 180 minus 52. So B is 128 degrees. Okay, these are vertical angles, so this should be 52. So I can take 52 plus 90 and subtract that from 180 to get this. And this creates a straight line, so 180 minus 38. So C should be 142 degrees. So you kind of have to work the puzzle and find all the missing things to figure out the rest of them. Okay, Okay, write equations for 3 different lines that contain the point 1, 3. Okay, so I'm not giving you any slope. So what I'm going to do is just write in, so this is x, this is y. So I'm going to use point slope. So I'm going to go y minus 3. Let's say my slope is 2. Okay, so there's one equation. And then I can do y minus 3 equals negative 1/2. So that's perpendicular. And then I could do y minus 3 equals 9 times x minus 1. Okay, they all contain that point, but they all have different slopes. Okay, if it asks for you to get it in slope-intercept form, we would distribute this to get 2x minus 2. We would add 3, so I'd get y equals 2x plus 1, and then you would have to do the rest of these as well by distributing and adding 3. Okay, a right triangle contains one right angle, so we're doing with vertices 3, 2, so I'm going to do that one first. So I'm going to go over 3 up 2, and then I'm going to go over 8 up 5, which is about right there, so that's G, that's H, and then K is 0, 10. I'm going to connect them. So it looks like my right angle might be here. Okay, so I could check to see if these are perpendicular lines. If these are perpendicular lines, to see if the slopes are opposite reciprocals, because if they are perpendicular lines, they should create a 90-degree angle. So I'm going to find the slope of GH. So I'm going to get 5 minus 2 over 8 minus 3, so 3 over 5. Now I got to see if KG here is going to be an opposite reciprocal. If it is, then they should be creating a right angle because they're perpendicular. So GK. So I'm going to get 10 minus 2 over 0 minus 3. 10 minus 2 is 8. Okay, so they are not opposite reciprocals of each other because that 5 and that 8. So because they're not, is not creating that 90-degree angle. So make sure, if you have to justify, you have to explain that these slopes are not opposite reciprocals of each other. Okay, we're going to graph this. So first I'm going to graph this. So I'm going to go up 8. And I'm going to go down 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5, down 3, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. Or I could go up 3 to left 5, so somewhere over there. Connect them. Okay, but my restricted domain this time is from 1 to 10 on my x-axis. So I'm looking on my x-axis here from 1, so from here to 10, from here. And then I want to erase everything that does not include that. So this is the only portion that I wanted. So you're going to have to check to make sure you're looking to see if it's on your x-axis or your y-axis. Okay. So we start with my given. So I'm just going to put an arrow up there to save some time. And my reasoning is given. Okay, so AB is parallel to ED. So I'm going to draw my little triangles in here to show that those are parallel. C is the midpoint of BD. Okay, if I have a midpoint, that means things are going to be congruent. So I started off with my given. So if C is the midpoint of BD, that means BC is congruent to CD by definition of a midpoint. Okay, so now I have those being congruent. Okay, it looks like I have some vertical angles in here that I can do, so I'm going to say angle BCA is congruent to angle ECD by vertical angles. Okay, so now I have a side and I have an angle, so now I need to prove something else. So if I have parallel lines, I'm probably going to have alternate interior angles. So let's go ahead and extend all my lines and my transversals. Okay, so I need it to be the one that's included in my angle and my side. Okay, so I either need it to be angle side angle, or I need it to be angle angle angle, or angle angle side. Okay, so it doesn't really matter, it looks like. I could pick, let's just do this one, and the alternate interior of that would be this one. Okay, so I'm going to say angle A is congruent to angle E by alternate interior angles. Okay, so in this situation, I'm going to have my angle connected to my angle connected to my side. So angle, angle, side. If you would have picked the other ones, then your shortcut would have been angle, side, angle. Okay, so if you would have picked this one and this one, it would have been angle, side, angle. Okay, so I'm going to go ahead and erase all this so we can actually see our picture again. Okay, so I'm going to say that the two triangles are congruent because we did the shortcut. So triangle ABC is congruent to triangle DEC by the shortcut, but I'm trying to prove this side. So I have to do that extra step. So I proved the triangle's congruent, so now I can prove any corresponding sides or any corresponding angles congruent. So AB is congruent to ED by CPC. Okay, it's always CPC. So you always prove the triangle's congruent, and then your next step is going to be that CPC if you have to prove an extra thing. Okay, so we start with our given. So I'm going to draw an arrow to save time. And then the reasoning is given. So I have JM bisecting angle JKL and JM being perpendicular to KL. Okay, so we have an angle being bisected, so I can say that these two angles are congruent. So angle KJM is congruent to angle LJM by definition of angle bisector. Okay, and then we have them sharing the same line, so we can say JM is congruent to JM by the reflexive property of congruence. And we still need another thing to prove congruent because all I have is an angle and a side. Well, I haven't used the fact that it's a perpendicular bisector, okay? It's not saying it's a midpoint, so I can't say, hey, these are congruent, okay? But perpendicular bisectors should create 90-degree angles. So I have to say that these are 90-degree angles, so angle JMK and angle JML are right angles by definition of perpendicular bisector. Okay, and here's the fun part. So we said they're 90 degrees, but now we got to say they're the same. So angle JMK is congruent to angle JML by definition of a right angle. Oh, that's not a, yeah, definition of a right angle. Okay, so now I have three sets of things that are congruent. So we're going to say angle, side, angle is my shortcut. So angle, side, angle. So angle or triangle JMK is congruent to triangle JML by angle, side, angle.